Hi, hello, this is Giri, teaching 10th Mathematics, the chapter sets. Here are the questions and solutions from exercise 2.3 and this is part 6 video. In this video, we will learn the questions and solutions from exercise 2.3. Dear children, questions and solutions from exercise 2.3. Here is the question number 1. Which of the following are equal sets? Here is the first bit. A is equal to set of x such that x is a letter in the word follow, and B is equal to x is such that x is a letter in the word follow, and C is equal to x is such that x is a letter in the word wolf. I shall repeat. Which of the following are equal sets? A is equal to set of x such that x is a letter in the word follow. B is equal to set of x such that x is a letter in the word flow, and C is equal to set of x such that x is a letter in the word wolf. Now let us see the solution now. Here all the three sets are given in set builder form. Good. All these three sets are given in set builder form. Now let us write these sets in roster form first. Roster form or list form. We are given that A is equal to x is such that x is a letter in the word follow. Now what are the different letters in the word follow? F, O, L and W. Only these are the four different letters. F, O, L, W. We know that no letter or no element should be repeated in a set. Therefore, the list form of the set A is equal to set F, O, L, W. Now set B. Set B is equal to x is such that x is a letter in the word flow. Again, what is the list form or roster form of this? We have to list out all the different letters in the word flow. The different letters are F, L, O, W. No letter is repeated, therefore nothing to worry. Now the third set C is equal to x is such that x is a letter in the word wolf. Now what are the different letters in the word W, O, L, F? Now if you observe all these three sets, the first set contains the elements F, O, L, W. Second set B contains the elements F, L, O, W. And the third set C contains the elements W, O, L, F. Please keep in mind that in any set, the elements should not be repeated. That is the first point. And second point is the order of the elements is not necessary. The order may be changed. You can change the elements at any place. From one place to another place, you can change the elements. The order of the elements is not important. But you should not repeat the element. Therefore, if you observe all these three, you can find the same letters or same elements in all the three sets. You can find the same letters. You can find the same elements in all the three sets. Since the elements are same, if we observe all the three sets A, B, C, then it is clear that all the elements of the three sets are equal. Since all the three sets are the same elements, therefore A, B, C are equal sets. Now question number 2. Consider the following sets and fill up the blanks with is equal to or not equal to so as to make the statement true. I shall repeat. Consider the following sets and fill up the blanks with is equal to or not equal to so as to make the statement true. Here A is equal to set 1, 2, 3. B is equal to set of first three natural numbers. And C is equal to set of A, B, C, D. And D is equal to set of D, C, A, B. And E is equal to set of A, E, I, O, U. And F is equal to set of vowels in English alphabet. Now if you observe this question, the set A, set C, set D and set E. These four sets are in list form or roster form. And whereas set B and set F are given in set builder form. Now let us convert all into roster form so that it is very easy to compare the sets. Therefore, the solution we have given that A is equal to set 1, 2, 3 and B is equal to first three natural numbers. What are the first three natural numbers? 1, 2, 3. Set 1, 2, 3. B is also set 1, 2, 3. And C is equal to ABCD, no problem. D is equal to DCAB and E is equal to AEIOU and F is equal to set of vowels in English alphabet. We know that the vowels are AEIOU only. Therefore, F is equal to set of AEIOU. Now the first bit A and B are given. Now are they equal? We have to find out. Look at A and B. The set A contains the elements 1, 2 and 3. Set B also have the same elements. Therefore, you can write A is equal to B. And the second bit A dash E. Look at A and E. The elements in A are 1, 2, 3, whereas the elements in E are AEIOU. The elements are different, therefore A is not equal to E. A and E, both the sets are not equal. Third bit C dash D. Look at C and D. The elements in C are A, B, C, D. The elements of D are also A, B, C, D. The order is different, but the same elements you can find in both C and D. Therefore, they are equal sets. C is equal to D. Fourth bit D dash F. Look at D and F. D contains the elements A, B, C, D, whereas F has the elements A, E, I, O, U. The elements are different, therefore D and F are not equal sets. Fifth bit F dash A. F set of vowels A, E, I, O, U and A contains the elements 1, 2, 3. The elements are different, therefore F and A are not equal sets. Now sixth bit D and E. D dash E. D contains the elements A, B, C, D and E contains the elements A, E, I, O, U. Again, the elements are different, therefore sets are not equal. D is not equal to E. Now question number 4. State the reasons for the following. I shall repeat. State the reasons for the following. First bit, set 1, 2, 3 and so on 10 is not equal to set x such that x belongs to n and 1 is less than x is less than 10. Second bit, set 2, 4, 6, 8, 10 is not equal to set x such that x belongs to n and x is equal to n plus 1. Third bit, set 5, 15, 30, 45 is not equal to set of x such that x is a multiple of 15. And fourth bit, set 2, 3, 5, 7, 9 is not equal to set of x such that x is a prime number. Here, in all the 4 bits, we have LHS and RHS. And all these are inequalities. Not equal to is given. LHS is not equal to RHS in all the 4 cases. It is given that LHS is not equal in all the 4 equations. Then we have to write the reason why they are not equal. We have to write here. State, I shall repeat the question you see. State the reasons for the following. Okay. Now let us see the solution now. First bit, in LHS, if you observe the LHS, the elements in LHS are 1, 2, 3 and so on up to 10. That is the numbers. These are the natural numbers starting from 1 to 10. Whereas if you look at the RHS, it is given that x belongs to n, okay, but x lies between 1 and 10. You see, x is greater than 1 but less than 10. Means x value is not equal to 1 and not equal to 10. The next value should lie between 1 and 10. That is, with respect to RHS, x is equal to 2, 3, 4, 5 up to 9 only. So the elements are different from LHS to RHS. That's why they are not equal. You see the solution here. In LHS, the elements are natural numbers from 1 to 10, but whereas in RHS, 1 and 10 are not included as 1 is less than x is less than 10. If it is less than or equality symbol in both places, then it will be right. It will be equal. If less than or equal to symbol is there in both the places, then this will be equal to LHS. But here only less than and symbol is there, therefore they are not equal. Now second bit, the set 2, 4, 6, 8, 10 is not equal to x such that x belongs to n and x is equal to 2n plus 1. Here what are these values? These numbers are even numbers. 2, 4, 6, 8, 10. All these are even numbers. But whereas if you look at the RHS, you have given that x is equal to 2n plus 1. 2n plus 1 and x is a natural number. 2n plus 1 in the place of n you can write 1, 2, 3, 4 etc. If you write n is equal to 1 you will get 3. If you write n is equal to 2 you will get 5. If you write n is equal to 3, 2, 3, 6 plus 1 is 7. Therefore, using x is equal to 2n plus 1, you are getting odd values at RHS, and in LHS we have even numbers. Since no even number is equal to odd number, both the sets are not equal. You see here reason. In LHS, elements are even numbers. The even number should be in the form of 2n. But whereas in RHS, the elements are odd numbers which are in the form of 2n plus 1. Therefore, they are not equal. Now look at the third bit. Set 5, 15, 30 and 45 is not equal to x such that x is a multiple of 15. Here, if you observe, what are the multiples of 15s? 15's multiples are 15 into 1 is 15, 15 2 is 30, 15 3 is 45, 15 4 is 60 and so on. But whereas if you observe, this 15, 30 and 45 are multiples of 15, but 5 is not a multiple of 15, 5 is the divisor of 15. Therefore, they are not equal. Look at the reason. In LHS, element 5 is not a multiple of 15, but RHS is a multiple of 15 set. Since LHS is not equal to RHS, that is the reason for the third bit. Now fourth bit. If you observe the fourth bit, 2, 3, 5, 7, 9, this is the set. And whereas RHS set is x such that x is a prime number. Now you see, 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, but 9 is not a prime number. Do you know what is a prime number? When can you say that a number is prime? Good. If a number has only two divisors, then if a number has only two factors, then that number is called a prime number. You see, 2, 3, 5, 7 have only two factors, whereas 9 has more than two factors. 1 can divide 9, 3 can divide 9 and 9 can divide 9. There are three factors for 9. Therefore, it is not a prime number. In LHS, element 9 is not a prime number, but RHS is a prime number set. Therefore, that is the reason for both the sets are not equal. Now, look at question number 5. List all the subsets of the following sets. List all the subsets of the following sets. First bit B is equal to set PQ. Second bit C is equal to set XYZ. Third bit D is equal to set ABCD. And fourth bit E is equal to set 1, 4, 9, 16. Look at the solution now. Here, before going to write the subset, it is better to know this statement that the number of possible subsets of any set with n elements is equal to 2 power n. The number of possible subsets of any set with n elements. If a set has n elements, then the number of possible subsets is 2 power n. For example, here if you look at B, how many elements that B has? The set B has 2 elements. If B has 2 elements, then the number of subsets of B is equal to 2 power 2, 2 square. 2 square is 4. Therefore, the number of possible subsets for B is equal to 4. Look at C. How many elements are there in set C? There are 3 elements in C. Then the number of possible subsets is 2 power 3. 2 power 3 means 2 into 2 into 2, that is 8 elements. If you look at D, there are 4 elements. Then the number of possible subsets for D, 2 power 4, 2 power 4 is 16. Therefore, there are 16 possible subsets for the set D. Okay. Now let us solve this question. First bit. Subsets of the set B is equal to PQ are. Now the number of subsets for B, we know that there are 4 subsets, and let us list out all the 4 subsets. For any set, we know that empty set is subset. Therefore, first write an empty set. Next, set with the first element and set with the second element and set with all the two elements. Here, empty set, set P, set Q and set PQ. These are the four different sets which are subset to B. This is an empty set. Empty set is always subset to any set. P. This P means in this set P is an element. Since all elements of this set is also an element of B, this is subset to B. Set Q. Here the element is Q. This element is also present in B. Therefore, every element of this set is also an element of B. Therefore, this is also subset to B. And set PQ. Set PQ means the elements are P and Q. All elements of the set PQ are also elements of B. Therefore, this is also subset to B. Please keep in mind, empty set is subset to every set. And the second point is, any set is subset to itself. Every set is subset to itself. Those 2 points you should keep in mind. For example, if we take B, for B, empty set is subset to B. And again, the same set B is also subset to B itself. Therefore, the number of subsets of B is 4, and they are empty set, set P, set Q, set PQ. Now, second bit, subsets of C, set X, Y, Z. Here there are 3 elements. Since there are 3 elements, then the number of subsets is 2 cube. That is, there should be 8 subsets to this set. First is an empty set. Next, write the sets with single elements. That is set X, set Y, set Z. Next, write all possible subsets with 3 elements. Set XY, set YZ, set XZ. These are the different possibilities. And finally, write all the 3 elements. Set XYZ. In this way, you can write the subsets of C. I shall repeat. You please see here. In order to write the subsets of any set, first of all write an empty set, a set with 0 elements. Next, write the different sets with single elements. Next, write the sets with 2 elements. Next, write the sets with 3 elements. Like this. In this process, you can write the different subsets of any set. You see, set XYZ. First we wrote empty set. Next, write subsets with single elements. Set X, set Y, set Z. Set X, set Y, set Z. Single elements. Next, 2 elements now. In each set there should be 2 elements. Set XY, set YZ, set XZ. At last, all the 3 elements. Set XYZ. In this way, you can write the different subsets of C. And the third bit, subsets of D is equal to set A, B, C, D. Here we have 4 elements now. Even though there are 4 elements, you may follow the same procedure. First, set with 0 elements, set with single elements, sets with 2 elements, sets with 3 elements, and finally set with 4 elements. First, an empty set. Next, set with single elements, set A, set B, set C, and set D. Next, the different subsets with 2 elements each. Means set AB, set AB, set BC, set CD, set AD. You see, set AB, set BC, set CD, set AD. And next, set AC, set BD. After that, you wrote all the possible subsets with 2 elements each. Now write the different possible subsets with 3 elements. Set ABC, set BCD, set ACD, set ABD, and set BCD. These are the different 3 element sets. And finally, a set with 4 elements, ABCD, the set itself. Now let us count how many are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 subsets of a set with 4 elements. We know that the formula that 2 power n, 2 power 4 is 16. Therefore, we did not miss any subset and we wrote all subsets of D. In the same manner, we can write the subsets of E is equal to the set 1, 4, 9, 16. Set with 0 elements, empty set. Set with single elements now. Set 1, set 4, set 9, set 16. Next, set with 2 elements. Set 1, 4, set 4, 9, set 9, 16, set 1, 16, set 4, 16, set 1, 9. These are the different 2 element sets. Next, sets with 3 elements. Set 1, 4, 9, set 4, 9, 16, set 1, 9, 16, set 1, 4, 16. If you finish writing all the possible subsets with 3 elements, then write the set with 4 elements. Set 1, 4, 9, 16. Like this, you can write all the possible subsets of any given set. This is question number 5. Thank you one and all.